Hi everyone, welcome to this lecture. So in this lecture, we learn how we can evaluate our model using a matrix known as confusion matrix. Now we have already transformed a linear regression problem into a logistic regression problem. We have already learned about the loss function of the logistic regression model. Now it's time to evaluate the model using confusion matrix. So basically, we made a confusion matrix from the testing samples of the data. That is, we split the data into training and testing. Then we train our logistic regression model on the training component of the data. And then we evaluate the model on a test data. Using test data, we create a confusion matrix and then we evaluate the performance of logistic regression classifier based on the confusion matrix. So how to construct a confusion matrix? So this is a confusion matrix of size 2 by 2. Its size is 2 by 2 because we have two labels, no and yes. So one of the important thing of the confusion matrix is its size. So the size of the confusion matrix depends upon total number of labels or target variables. So if we have two labels, the size of confusion matrix will be 2 by 2. If we have three labels, then its size would be 3 by 3. The other thing about the confusion matrix is that it is a square matrix. That is, rows and columns are same. So the size of the confusion matrix is either 2 by 2, 3 by 3, 4 by 4, 5 by 5. So it will be a square matrix. The third thing about the confusion matrix is that it has also the axis. This is the vertical axis of the confusion matrix, and this is the horizontal axis of the confusion matrix. These are the four elements of a confusion matrix. So in this case, we have a confusion matrix of size 2 by 2 because we have two labels. Now I have a testing samples equals to 215. Now with the help of these 200 testing sample, how the confusion matrix will be created by the model during the testing. So basically, if we see, it has divided these 215 samples into four elements. Here we have 50, here we have 10, we have 5, and we have 150. Let's understand each element separately. So this 50, what about this 50? This 50 is at the intersection of two things, that is actual no and predicted no. So what does it mean? It means these 50 samples are those whose actual label is no, and model is also predicting no. So these 50 samples are correctly classified by the model when they were actually no, that is, they belongs to a class no or they belong to the negative class, and the model also classifying them as a negative. So it means these 50 are the correctly classified sample. Now look at these 150 samples. So they are at the intersection of actual yes and predicted yes. It means these 150 sample belongs to a class yes or belongs to a positive class, and model is also predicting them as a yes or as a positive class. It means these 150 samples are also correctly classified by the model. So these 50 and these 150 which are present at the diagonal of this confusion matrix are those number of samples which are classified correctly by our model. Now what about this 10? So here is a value 10, and we can see that this 10 value is at the intersection of actually no and predicted yes. So what is happening over here? Basically, these 10 samples belong to negative class. So in reality, these 10 sample belongs to a negative class, and our model is saying that they belongs to a positive class or a yes class. So these 10 samples are wrongly classified sample. Similarly, these 5 samples are also wrongly classified sample. That is, actually they belong to a positive class, that is yes, and model is saying that they belong to a negative class. So model is not predicting these 10 and 5 correctly. It means out of 215 samples, these 50 and these 150 samples are correctly classified by the model. On the other hand, these 10 and these 5 samples are not correctly classified by the model. It means now with this information that these two samples are correctly classified and these two samples are not correctly classified, we can easily discuss the accuracy of the model. That is, the total samples are 215. So out of 215, 200 samples are correctly classified and 15 samples are not correctly classified. It means if I divide this 200 by total of 215, I will get the accuracy of model. So in this way, from the confusion matrix, by observing the correctly classified samples and the wrongly classified sample, we can easily calculate the accuracy of a model using confusion matrix. So here we can see that if I want to calculate the accuracy with the help of this confusion matrix, so I have total correct guesses or total guesses. So total correct guesses are 150 over 150. This is the correct guess because it belongs to negative class, and model is also saying that it belongs to a negative class. This is also correct guess because it belongs to a positive class, that is class whose name is yes, or a positive class, and model is also saying that it belongs to a positive class. So these are two the correctly classified samples. So we divide them, we add them and divide by the total number of guesses. So we get 0.93 accuracy. And if we transfer into the percentage, they will be 93%. Now every element in the confusion metric has its name. So here are the name of these elements. So this 50 or this part or this element of the confusion matrix is called true negative. This is called false positive. This is called false negative. And this is our true positive. So these are the four names of the elements present in a confusion matrix. Now name is defining everything. This is true and these are negative. So basically these 50 samples belongs to negative class and model is predicting them truly. Similarly, these 150 samples belongs to positive class and model is predicting them correctly or truly. On the other hand, these 10 samples basically belongs to negative class. So model is saying they belongs to positive. So model has classified them as a positive, which is false. So that's why it is known as false positive. Look at these 5 samples. So these 5 samples actually belongs to the positive class, but model is saying that they belongs to the negative class or the class whose name is no. So model is predicting them wrongly or falsely as a negative. That's why they are called false negative samples. So these are the 4 important names of the elements which are present in the confusion matrix: true negative, false positive, false negative, and true positive. So the false positive and false negative, the samples belongs to these categories are wrongly classified. So basically these two values are the error of the model. Here the model is correct. There is no error when we have only true negative and true positive. On the other hand, false positive is an error and false negative is also an error. So these are the definition of true positive and true negative. A true positive is an outcome where the model correctly predicts the positive class. Similarly, a true negative is an outcome where the model correctly predicts the negative class. So both these true positive and true negative indicates those samples which are correctly predicted by our model. On the other hand, we also have false positive and false negative. So a false positive is when a model predicts positive when it is not a positive or it is negative. False positive is also known as type 1 error. So we have to remember this name as well. Since we have already learned that false positive is an error, now the name of this error is known as type 1 error. Similarly, false negative is also an error and the definition is when a model predicts negative when actually it was positive. So false negative is also an error and it is known as type 2 error. So we have to learn about this type 1 and type 2 error. We have to remember the name of type 1 and type 2 error. So in this lecture, we learn about the confusion matrix. We learn that we can create the confusion matrix and the size of confusion matrix is equal to the number of target variables. So if we have two target variables, no or yes, or a negative and a positive target, in that case, our confusion matrix will be 2 by 2. So inside the confusion matrix, we have 4 important terms named as true positive, true negative, false negative, and false positive. So true negative and true positive are those samples which are correctly classified by the model, whereas the false positive and false negative are those samples which are wrongly classified by the model. Therefore, these two are called the errors of the model. False positive is also known as type 1 error, and false negative is also known as type 2 error. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.